I would like to use Minitab Express to find cumulative probabilities or areas to the left of a z-score. So I want to find the probability that z is less than 0.70, less than 1.67, less than negative 2.83, and less than negative 0.18. I've done these examples before using the TI-84. Now I want to take a look at how to get these using Minitab Express. So to get the probability that you get a z-value less than 0.7, you want to click on your Statistics tab and go over to CDF/PDF. This is the same screen we went to when we were working with the binomial distribution. And we want the cumulative distribution function. And our input is a single value. And in this part, I want to find the probability z is less than 0.7. And click on OK. And looking at my output, and scrolling down, the probability x is less than or equal to 0.7. Now, technically, this should be the letter z if we're working with the standard normal, but that's okay. The x value represents the number along the horizontal axis. So that probability, or the area under the bell curve for the standard normal distribution, is 0.758, rounded to 3 decimal places. Now, one thing that's cool about Minitab Express is I can get a visual of this. If you click on your distribution plot and scroll to display probability, you'll see that the default setting is for the standard normal distribution, where the mean is 0, standard deviation is 1. If you click on or select a specified x value, and indicate we want a left tail area, that means that we want the probability to be shaded, or the area to be shaded to the left. So if we were finding a probability that z is less than 0.7, less than would indicate we're shading to the left. And then I'm going to put that x value, which is actually a z-score, right there, and OK. And let's take a look at that. You'll see that it graphs the standard normal distribution and shades the appropriate area, and that is the same area that we got before. Now let's do the other ones. I want to find the probability z is less than 1.67. So just to get that individual answer rather than the graph, I click on CDF/PDF, cumulative distribution function. My value is 1.67, and click on OK. My cumulative probability is 0.953, rounded to 3 places after the decimal point. This is consistent with where z is placed. Z is above 0, so I expect that area to be greater than 0.5. If I want to get this in terms of a graph, again, click on distribution plot, scroll to display probability. We want a specified x value, and I want it less than, so that's going to be the left tail case, and putting in 1.67. I'll get the same area, but you can see that it's shaded to the left of 1.67. Now let me quickly do the other two. Let's find the probability z is less than negative 2.83. Going back to my CDF/PDF option, cumulative distribution function, the value now is negative 2.83. Since this z-score is below 0, I expect that area to be less than 0.5. And you'll see that this is a very small area. So visually, going to the distribution plot, down to display probability. Again, I want a left tail and a specified x value. Negative 2.83 is my input, and my output will be this shaded area. Okay, so an area or a probability of 0.00233 is very small. Last but not least, let's find the probability z is less than negative 0.18. So going back to my cumulative distribution function, putting in negative 0.18, this z-score is a bit closer to 0, so I expect that area or probability to be much closer to 0.5. But it will be less than 0.5 because I am below 0 on the standard normal curve. You will see that this probability is 0.429. Last but not least, let's go ahead and take a look at that in terms of a graph. Selecting distribution plot, clicking on display probability. I want a lower tail option that is equivalent to a cumulative area or probability, and I'm telling it I want my input to be an x value or a z-score first, so putting in negative 0.18 and click on OK. In fact, we're pretty close to 0. The output is a little smushed right here, but you'll see that this area is a lot closer to 0.5 than the previous example.